Because of Mars' low atmospheric pressure and low temperatures, water can't exist in liquid form. It must either freeze or evaporate. But while there are no oceans or rivers on Mars, there is more water in total than anyone had expected. The residual polar cap in the north, which remains after the hottest part of the northern summer, is water ice mixed with dust. And the measurements of the seasonal behaviour of the water vapour over the planet suggests there is a vast reservoir of ice beneath the surface, so that one can think of the residual polar cap as the tip of an iceberg protruding from a sea of rock. At lower latitudes, a water vapour condenses to form clouds that ride high in the atmosphere or swirl around the slopes of Martian volcanoes. And further south in the canyons and valleys, there is frequently an ice haze seen to form and evaporate in the early hours of the morning as the sun warms the atmosphere. In this model, the flat surface of a large Martian plateau is cut by the Great Rift. A smooth, sloping ravine drops abruptly to the bottom of the canyon 4 miles below. The small peaks on the canyon floor were once part of the plateau's surface. Today, this great fracture in the crust of Mars is 75 miles across. The original fault has been widened and shaped by various forms of erosion. Great landslides are triggered by quakes that shake the crustal rocks. Wind-blown dust strips the canyon walls. Some side canyons may have been deepened by running water. Melting of underground ice, followed by slumping of walls, further erodes the Great Fault. This Rift Valley, of which we have only seen a small part, is so huge that it would span the United States, and the Grand Canyon of Arizona would fit inside one of the smaller tributaries. These are just some of the mysteries of Mars, unlocked by the extraordinary Voyager missions.